大家好 Welcome to GTC Taiwan. So great to see all of you. Very good to be home. I brought my parents home. Where are my parents? Everybody give a round of applause to my mom and dad. And I have so many partners to thank. It is incredible how large our ecosystem in Taiwan has become. Most of the time, when people think about ecosystem, they think about our software stack. They think about the developer ecosystem above the computing systems that NVIDIA builds. But NVIDIA's ecosystem spans all the way upstream to all of our supply chain here in Taiwan, where it all begins, and downstream all the way to data centers and eventually to end users. Today, we're going to talk about almost all of the ecosystem. There's so many people to thank. I love my ecosystem here. I mean, there are so many companies here, and some of my favorite ecosystem partners. So many. Taiwan's rich ecosystem, the richest ecosystem, the world's best supply chain ecosystem. Unbelievable. Well, thank you all for being here. And this year, our businesses together are growing incredibly. In fact, somebody told me last night that the annual GDP of Taiwan is going to grow almost 10%. Unbelievable. Well, we have a lot to talk about. Let's get going. 2 years ago, when I was here, I started to talk to you about how AI has moved from generative AI and the other waves of AIs that are coming. The next wave of AI was Agentic AI. And today, we can say that Agentic AI has arrived, that useful AI has arrived. Now, what does this mean? This is GitHub. This is, of course, one of the first applications of Agentic AI is software coding, one of the most valuable professions. Incredibly large ecosystem, 30 million, 40 million professional software developers, probably another couple of hundred who are students and enthusiasts and so on and so forth. But say 30, 40 million software developers in the world code for a living. And this represents most of them. This is GitHub. The pull request is when they download software, they modify it, and commit is when they push it back up. Okay? And so if you could look at this, in 2023, the number of commits was 300 million. 2024, 400 million. 2025, 500 million commits. In the first few months of 2026, it has nearly tripled. Now, what does that mean? 30 million software developers representing about $3 trillion worth of GDP, producing that's what they're paid, $3 trillion worth of salaries per year, which is generating economic growth for the rest of the industries. Say $100 trillion of the world's industries is generated by $3 billion worth of salary. That $3 trillion worth of salary is now producing nearly 3 times as much output. It's effectively a $9 trillion productivity from $3 trillion of salaries. Does that make any sense? The difference is absolutely extraordinary. This is the potential. This is the promise of AI. The number of engineers, software engineers, is actually increasing. People talk about AI reducing jobs. Complete nonsense. It's causing more software engineers to be hired. And the reason for that is very simple. If you can hire a software engineer and you could generate $9 trillion worth of productive work, it has to understand, observe, reason, act, use tools. That tool could be a spreadsheet, web browser, a data processing engine, database engine, for example. This is orchestrated, this harness orchestrate this routing of information every single time it touches either processing the context, understanding what is happening, reasoning about what to do, coming up with a plan that it acts on. That orchestration path is orchestrated by some software. And so this is fundamentally an agent. It deals with short-term memory, called working memory, long-term memory, just like we have long-term memory. And so the memory management system is incredibly important. This entire system is called an agent. The large language model is used to do the thinking, and the harness connects everything together, just like an operating system, okay? And so this is the new computing model, and this is what an agent. It could do incredible things. This is the big breakthrough. The simultaneous convergence of large language models that are now able to do a really good job thinking, reasoning, planning, using tools, and the fact that we have now these harnesses that manages memory, the orchestration, uses tools, we can now do amazing things. Let me give you some example. This is a prompt. This is the prompt. This is the code that is generated, and this comes out. This is the input. This is the input, and that's the output. What do you guys think? It's pretty amazing, right? We use Claude Code here, but Codex does an incredible job as well. Here's another example. This is the input, create a GIF, and Vera Rubin. Vera Rubin is not one chip. Vera Rubin is not a GPU only. It starts with the GPU, but Vera Rubin is incredible. This entire thing is Vera Rubin, from end to end. It has GPUs, Vera Rubin NVLink 72. It is orchestrated by Vera CPUs that I'm going to tell you more about. The storage systems, revolutionary. Vera, along with CX9, our software stack called Doka, the security processor that's inside so that everything is encrypted at rest, in motion, as well as in use. Everything across this is secure because the AI model is so precious. This is the reason why this entire system obeys confidential computing. Each one of these systems would be a complete revolution in itself. Vera Rubin is the most ambitious endeavor in the history of our company. The whole company worked on Vera Rubin across all 40,000 engineers. Not to mention all of you. All of you participated in the creation of this entire system. Vera Rubin is really a miracle. And it's not just one chip, it is so many. Well, it's even beyond that. A long time ago, NVIDIA used to be a GPU company. But over the years, we've evolved to become a systems company. You're looking here now for the most complex system, most complex and ground-up system ever designed. But ultimately, our customers, our partners, don't want to buy computers. They want to build AI factories, which is the reason why NVIDIA has really started to transform ourselves yet again. You could see so much of our technology is now at the entire infrastructure scale. Our partners are at infrastructure scale. Power generators, cooling systems, the grid providers. So many industrial companies are now part of our ecosystem because ultimately we're trying to build an entire stack, just like GPUs, just like when we were building Grace Blackwell NVLink 72, just like now, we are building a full stack system so that our customers could build amazing AI infrastructure. Let's take a look.
The world is racing to build AI factories, the largest infrastructure build-out in human history. AI factories are incredibly complex. Every layer, chip, rack, network, power, cooling, grid, must be designed together from end to end, because compute is revenues. NVIDIA DSX is the blueprint, a reference design for building and operating AI factories at maximum efficiency and profitability. It starts with DSX Sim. With the DSX Sim Omniverse blueprint, partners design and validate an NVIDIA Vera Rubin AI factory before a single rack lands. They plan the layout, simulate the power and cooling, design the network, validate every integration, test every change in the digital twin. The factory powers on. DSX OS takes over and provisions, operates, monitors, and remediates the infrastructure, turning the installed systems into trusted, multi-tenant, resilient, AI-ready capacity. Today's AI factories over-provision power by up to 40%. DSX Max LPS lets operators safely deploy more GPUs inside the same power budget, adding billions in annual revenue. Breakthrough hot liquid cooling at 45 degrees Celsius uses less water and energy. More power going to revenue-generating compute. Incredible. Dynamic power allocation steers power from rack to rack, recovering stranded watts, sending them where work is happening. In-rack power smoothing flattens peak current spikes and power surges. Throughout the factory, teams of AI agents work with DSX Max LPS, continuously coordinating to balance cooling and power to meet workload demand. DSX AI factories are flexible energy assets that operate cooperatively with the grid. DSX Flex reads real-time grid signals and dynamically adjusts factory power when the grid needs relief. 100 gigawatts of AI factories will come online before the end of the decade. NVIDIA DSX AI factories run at highest efficiency, produce the lowest cost tokens, and make the grid stronger.
I've shown you ecosystem slides of the past, where NVIDIA's computing layers and software and computing stacks are integrated into other people's platforms, third-party platforms and libraries that serves end markets. That was a computing ecosystem. This is an AI factory ecosystem. This is way downstream of all of you. Upstream of me is all of you, and downstream of us is this ecosystem. Because NVIDIA ultimately is not just building a GPU, not just building a system. We're helping customers build these AI factories, these AI infrastructure that is so immensely complex. Each one of these at 1 gigawatt level started at $30 billion. It is at $50-60 billion, and soon it will be $100 billion per gigawatt. $100 billion into an AI factory. It must work the first time, and it must work right away. The cost of capital is incredible. The complexity is incredible. So as you see, we used to design a chip inside a computer. And then we simulated a system inside a computer. Today, you saw just now, everything was built in Omniverse. I've been working with Omniverse with all of you for a long time. This was the dream come true, so that we can build these gigantic systems as large as the world wants to build inside a digital framework, inside a digital simulator, in a digital world, long before we build the first break ground and put our money to work. So this is our ecosystem. We call it DSX. RTX is for our GPU. DGX is for our systems. and now DSX, basically infrastructure. Because of the work that we do here, across this entire stack, including our systems and software, it's the reason why we could work with small companies and enable them to be world-class AI clouds. Every one of these I'm about to show you are small companies just recently. And now CoreWeave is worth 50, 60, 70 billion dollars and growing incredibly fast. Recently, we worked with Nebius. And again, they're growing. AI has completely changed. We started out talking about CNNs. Here we are, then we talked about transformers. And then we talked about mixture of experts. Now we're talking about agentic systems. Every single generation, every single few months, the software industry is coming up with new technology. If your architecture is not flexible, if your ecosystem is not rich, then this curve cannot be long. You cannot predict how long your system can last. I can. NVIDIA systems is all over the world. Software developers start with NVIDIA CUDA. And by definition, therefore, the life, the ecosystem, the useful asset is going to be much longer. The difference is essentially cost. You could think of it as revenues, but the other side of revenues is cost. If the life of the asset is long, the TCO is low. This is the difference. This is what it looks like when compute. The more you buy, the more you make. Now, all of you are experiencing this with me. Isn't that right? All of your demand, your factories are working so hard. Your people are working so hard all across Taiwan because everybody wants to make money. They realize that AI, useful AI is here. Profitable AI is here. Compute demand is incredibly high, and compute demand is the constraint. And so let's go work super, super hard and help the world stand up AI factories everywhere. This is why it's so important. I'm so happy. Here I am standing in front of you. Vera Rubin is in full production. Vera Rubin is in full production. The supply chain we created for Vera Rubin is twice as large as Grace Blackwell. It's incredible. And what used to take 2 hours to assemble one Grace Blackwell rack now only takes 5 minutes. So not only is the capacity higher, the throughput is a lot faster, and we need it all to support the demand. This ecosystem is extraordinary. Millions of square feet has been put online to support Grace Blackwell and preparing now, ramping up now, Vera Rubin. I want to thank all of you. Vera Rubin is now in full production. Thank you. This is Vera Rubin. Vera Rubin NVLink 72. This is the Grok LPX. At the next GTC, I'm going to talk to you about a lot more of this. Today, we have so much to talk to you about. This is Vera CPU rack, 256 CPUs, all liquid cooled. Let me tell you about Vera in just a moment. This is the Vera Bluefield storage processing system and also security system. And of course, this is our Mellanox networking, the world's first CPO. This is Vera Rubin. Incredible technology all coming together. Now, when we built Hopper, as you know, for pre-training. Pre-training was the most important application, the most important workload we were working on at the time. Then when we worked on Grace Blackwell, everybody said, Jensen, NVIDIA is really good at pre-training. Inference is so easy. Do you remember that? People used to say, inference is so easy. We could do that too. But as you know, inference equals money. And the models, MOEs, are so complicated. And to do it at incredibly high response time, fast interactivity, and high throughput at the same time is incredibly hard, which is the reason why we created NVLink 72. Today, NVIDIA's token cost is the lowest in the world. This is the most expensive for a good reason. The economics of the AI factory is tokens. And the tokens are created here. And so, of course, you want to manufacture and generate as many tokens as possible. This is where you put all of your economics. And this has to not be in the way. And so Vera CPU has great pressure on the CPU architecture, which is the reason why we built a brand new architecture from the ground up. A CPU the world has never seen before. We call it Vera. This is CPU for agents. All the CPUs of the past, we built for humans. This CPU is built for agents. Well, there are 4 things to keep in mind. The 4 takeaways. The first takeaway is that the instructions per clock of Vera has to be incredibly good because we need the latency to be short. We need the processing time, single-threaded performance. Not throughput, single-threaded performance has to be world-class, absolutely the best. Single-threaded performance, which is the reason why the IPC, the instructions per clock of Vera, is so high. It's the highest in the world. 10 instructions fetched, decoded, and executed per clock. Number 1. Number 2, the bandwidth necessary to move data in and out for the CPU has to be utterly world-class. The second thing is bandwidth per core. The third is just bandwidth, period. We're moving, remember, I said earlier, agentic systems is fundamentally disaggregated and distributed. Disaggregated and distributed. When computing is disaggregated and distributed, networking becomes the problem. Therefore, we have to move the data around as fast as possible between the CPU cores and between the CPU and the storage, the CPU and the GPU. The bandwidth around the system and inside the CPU core has to be utterly world-class. This is the first CPU that's been built a long time that is literally at reticle limits with a fabric that connects all of the CPU cores that is speed of light. 3.6 terabytes per second. No chiplet tax, no chip boundary crossings, because we need to have everything, because the CPU cores are talking to each other with extremely high bandwidth. They're not rented core per core per core. They're all working together. The cross-sectional bandwidth of Vera is off the charts. It's the first one to be PCI Express Gen 6. It is also the first one to have LPDDR5 with 1.2 terabytes per second. 2 to 3 times the bandwidth of the highest performance CPUs on the outside, 3 times the bandwidth on the inside. The bandwidth per core and the bandwidth period is world-class. Now remember, I showed you earlier, the number of CPU cores, the number of CPUs is going to be quite high. And the reason for that is very simple. We created CPUs for humans in the past. And humans, there are only 1 billion of us. There will be billions of agents. And these agents are going to be using the CPUs with very little patience because the cost of the GPU they sit next to is too high. And therefore, too valuable, too precious. Therefore, these CPUs are going to be both performant, but they also have to be extremely energy efficient so that we can cram as much CPU as we can into the factory without taking away power from the token generation, which we know is how we make money. These 4 properties, instructions per clock or single-threaded performance, bandwidth per core, the total bandwidth around the chip and inside the chip, and energy efficiency defines Vera. It is absolutely world-class. When you compare it to the highest performance x86, it is just off the charts. When you compare it in real single-threaded performance, it's off the charts. It is incredible to be able to deliver 5% improvement on CPUs. It is incredible to be able to deliver 10%. But this kind of performance speed up is just unheard of. This is NVIDIA Vera. What do you think? You're going to see so many companies adopt it. Red Hat, Canonical, Microsoft. It's going to be adopted everywhere. This is the runtime. And this runtime is fully optimized for the NVIDIA AI platform, which is everywhere. So you can run OpenShell in any cloud, on-prem, and even on device. So you have now tools and libraries that they can use. You have models that you can modify or use as is, or you have agents. This would be OpenClaw, Hermes, another incredible harness. These agentic harnesses can now run on-prem or for you anywhere, okay? So 4 things, and this represents the operating system of the modern enterprise. Now, how do we use this? One of my favorite use cases of agents is chip designers. It is the single most important thing that NVIDIA does. And so, of course, we have to partner with Cadence to build Super Agent, a chip design super agent. It is orchestrated by Codex or Cloud Code. It has RTL and architecture diagrams today. Each one of these elements were essential in making the PC so popular. 40 years later, Microsoft and NVIDIA are going to reinvent the PC. This is going to be the new PC. Now, tomorrow night, I think it's tomorrow night our time, but I'm going to be with Satya, where we're going to talk a lot more about the work that we're doing together. Microsoft and NVIDIA, over the last 3 years, it took this long to completely reinvent how the PC is going to work so that we could be ready for this moment. As I mentioned earlier, that compute pattern called the agent is going to run in AI clouds. It's going to run inside enterprises. It is also going to run on your PC. What's going to happen to that PC when it has an autonomous agent? An agent that's helping you, that understands you. You could talk to it. It could look at you. You could ask it to read files, go help you do some research. It could do a lot more that I'll show you. But the new operating system is, of course, the old operating system plus large language models. Large language models, in a lot of ways, is the modern version of DirectX. It has, of course, input and output, understands prompts, it understands computer vision, it can generate video, it can generate sounds. It is the modern extension, the intelligence extension of the PC, of a computer. On top of that, the application, as I mentioned before, is going to be replaced by now an agentic runtime. And that is the modern application, an agent. Let's now take a look at what it can do.
It started with a spark, an idea, to reimagine the PC for the first time in 40 years, for the age of AI. What becomes of our personal computer in a world of agents? Agents running natively, connected to models, local or in the cloud. Our personal AI, sandboxed for security, running continuously, getting work done. The chips and the OS must evolve. Introducing RTX Spark. Everything we've learned over 33 years distilled into one chip. Blackwell RTX GPU with 6,144 CUDA cores, 1 petaflop of AI performance. A custom 20-core Grace CPU built in partnership with MediaTek. Fused by NVLink. 128 gigabytes of unified memory, TSMC 3 nanometer process, 70 billion transistors. And in close collaboration with Microsoft, a Windows platform for agents. We're reinventing the personal computer for creating, for gaming, for agents. This is the dawn of a new personal computing revolution. And it starts with NVIDIA RTX Spark.
Here it is. Of course, I got to show you the most beautiful part, which is video games. It's also the closest to our heart. This is Forza. This is 007, by the way. The new 007 game, I'm looking forward to playing it. I look a little bit like him. Ladies and gentlemen, NVIDIA's RTX Spark laptops. Now, thank you. I have too many things in my pocket. 太多东西了. Okay, all right. This is the most amazing chip the world has ever built. This is the N1X that we built in partnership with MediaTek. I think I saw Rick earlier. This is N1X. This is a beautiful chip. This is a chip that, frankly, would take 33 years to build. And the reason for that is because 100% of NVIDIA software stack runs here. If you want to run digital biology, no problem. If you want to do seismic processing, no problem. You want astrophysics, no problem. Everything associated with CUDA, all the physics, all the biology, all the genomics, all the AI, no problem. All the computer graphics, no problem. Every single application NVIDIA has ever created and every single application that Windows has ever run. Microsoft and NVIDIA meticulously optimized everything so that this computer literally runs everything the world has ever created, plus it now runs agents. An incredible computer. I'm so proud of it. Okay, now I want you to keep that in mind in the next video I'm going to show you. Just imagine everything here is going to run on your PC. Now that computer could have a local Nemotron 3 Ultra model or Nemotron 3 Super model, or it could have Claude Code or Codex or some other model in the cloud or something on the network. And it's going to work and do something amazing. Let's play it.
Every house starts as an idea. Getting from idea to design takes a myriad of tools, expertise, and a lot of time. Now, an agent running locally on RTX Spark can help me design a house using the tools on my laptop with an OpenShell sandbox, running the Hermes harness connected to Claude Sonnet in the cloud. I select the site, share my concept sketches and mood board of styles to inspire my design. And the prompt, a text description of the requirements and the design intent. My agent goes to work. Using the tools on my laptop, it opens Rhino and starts modeling the site, shaping terrain, setbacks, and the building envelope. Then it proposes building forms, optimized for cost, comfort, and quality. With the form defined, my agent generates the interior layout. Walls, circulation, rooms begin to take shape. I jump in whenever I want, to adjust, to change. Doors, windows, and structural elements are placed automatically. My agent detects its own mistakes and fixes them. When I approve, the agent exports the model from Rhino into Blender. Materials and object properties transfer with the design context intact. I fine-tune the materials, get the look just right. Then, I pick the shots. Blender renders the house. My agent, using generative AI with the Flux 2 model, makes them photoreal. Multiple viewpoints, lighting conditions. What was once a complex workflow is now guided and simplified by my agent. Working with me on RTX Spark. Design at the speed of imagination.
PC in the world of agents. The developers are so excited about it. This is an incredible computer. All of the acceleration, all the software capabilities associated with it, working with every developer to make it incredible for all of you. The next one, Adobe. Incredible tool suite, of course, used by tens of millions of people around the world. They have re-engineered the architecture, the core of Adobe Photoshop and Premiere, and they'll release it for RTX Spark. It is twice as fast. It's already fast. Now it's going to be twice as fast. And it's also designed to be agent-friendly. With its MCP server, it can now interact with agents on your laptop. The number of customers, the number of partners that are so excited to bring RTX Spark to the market is just incredible. You know, this is the first across the lineup of PC reinvention for 40 years. And I'm just so happy that all of you and the ecosystem around the world has joined us. This is basically everybody. Everybody will support RTX Spark and will be building incredibly smart and powerful and beautiful laptops with all of us. Thank you very much. But that's not all. That's not all. RTX Spark is a reinvention of laptop. But in fact, Microsoft and NVIDIA is reinventing all of PC. And today we're announcing a whole new line. 3 revolutionary Windows machines covering desktop, laptop, and workstations. All 100% Windows compatible, 100% CUDA, 100% NVIDIA AI Tensor Core. Everything that you see that runs on NVIDIA in all these different platforms around the world runs here. This is the first completely re-engineered, reinvented line of PCs that has happened in 40 years. Now, what's really amazing is this. So this is the RTX Spark laptop. This is the desktop. So this one's from MSI. Joseph, this one's yours. Okay. Look how beautiful it is. This agent could run 24/7, meter-free. And you could download your agent. You could raise your lobster in here. This is your claw. It's running all the time. No meter anxiety. And it's sitting here connected to your whole house, connected to your laptop, connected to your display, all the cameras, your dryer, your water cooler, your water heater, your everything, whatever you want. Your security system, all connected to this, and this becomes your personal AI, your personal AI agent. And it gets smarter and smarter and smarter over time because today we have Nemotron 3 Ultra, tomorrow we have Nemotron 4, and then Nemotron 5, Nemotron 6, and we just keep getting it smarter and smarter and smarter. And meanwhile, this is sitting at home helping you do things. If you want to book a travel, no problem. And if you want an incredible system, this is a DGX station for Windows, compatible with Windows, runs everything in Windows, and it has 768 gigabytes of memory. And so you could run a trillion parameter model. This is unbelievable. 20 petaflops, 8 terabytes per second of memory bandwidth, and this sits by your desk. You basically, if you're a developer of large language models, you're a developer of agents, having this sit by your desk gives you all the compute you need, and then when you deploy it, you put it into the cloud. Now, there's something that, if you look at this and think about this, something is happening here. Remember, 15, 20 years ago, we used to have an idea called a phone. Today, we have an idea called a PC. Today, when you think about your phone, the one thing you don't do with it is make phone calls. You do just about everything else. And so that phone means something very different to you than a phone of the past. I am certain what's going to happen here is that the PC 10 years from now and the PC that you think about today, a tool, whether you launch applications, click and type, and this PC is going to be completely different. Here's my theory. I can totally imagine, just as every house today has a home theater, where many houses have home theaters, big TVs, lawnmowers, dishwashers. I could totally imagine that someday there's actually an AI supercomputer in your house. And it's running all of your agents, it's running all of your assistants. And they're doing all kinds of things for you all the time. And you have to have it in your house, just like you have a home theater in your house, you have stereos in your house, you have game consoles in your house. You would have AI agent computers running in your house. And these, in time, becomes a lot more like R2-D2 to you. It becomes more like C3PO to you than it feels like a PC to you. There is no question this reinvention of the computer is as big of a deal as the reinvention of the phone into what we now know as the smartphone. And so this is the beginning of that journey. This is the beginning of a new line. And so we have a roadmap for this. This is a brand new product family for us. Every single generation of architecture, we will have a desktop, a laptop, a workstation, and then a desktop, a laptop, and workstation. And the thing that I am just incredibly pleased, incredibly honored, is that 100% of the world's PC industry has joined us to reinvent the PC. Industry has been completely changed. In the last 6 months, everything changed. Everything changed because agents were realized, and it converged with the latest frontier models, and it made possible the AI to now do useful work. The computing pattern will repeat over and over and over again. This computing pattern of an agent that's a model, a harness that uses tools with skills and runs in a runtime. That runtime depends on whether it's in the cloud or on-prem, on a PC, or in a robot. But the computing pattern is exactly the same for all of them. You will use different harnesses because of your preference. You will use different models because of your preference. You will improve them for your proprietary use. You would create super agents that you can rent to other people to help them do their work. This agentic platform, this agentic pattern, NVIDIA has an enterprise AI toolkit. This is a wonderful way for all of you to engage AIs, and for us, it's a wonderful growth opportunity. Vera Rubin is in full production, whereas Grace Blackwell was created to process AI, particularly inference. Vera Rubin was created to run agents. It is in full production. It is much, much more than a GPU. It is an entire disaggregated, distributed agent processing system. NVIDIA has really become an infrastructure company, not just a GPU company, not just a systems company, but an infrastructure company to help you generate the maximum revenues, the maximum profit, and to get there as soon as possible. The agent world, this new way of doing computing, where you build CPUs now for agents, not for people. CPUs for agents has its own special requirement, and our NVIDIA Vera is revolutionary. I'm so happy about its ramp. The orders already is going to make it the fastest and the most successful product launch in our company's history. NVIDIA and Microsoft has created a whole new line of PCs. This is a new beginning. And of course, that exact same agentic processing pattern, computing pattern that I just described is also going to run on all kinds of devices. I mentioned PCs, but in the future, it'll be robots and satellites and base stations and factories in the cloud on-prem at the edge. This pattern, Agentic AI system, this agentic computing pattern will be replicated in computers all over. How we think about the personal computer will very likely change. I want to thank all of you for your partnership, your friendship. We couldn't be here without everything that we do together. I am so proud of how you've been so successful this last year. The next year is going to be even more. I have one more thing for you. Let's take a look.
You ready, Taiwan? Let's do this.
The keynote's done at Computex. Jensen showed the world what's next. Useful AI has arrived. Agents working by your side. But in case you missed things we said today, we're gonna break it all down for you, Taipei.
Agents used to be misunderstood. Only movie stars had them in Hollywood. Now we all got teams making dreams come true. Building companies from living rooms. But they need so much compute, we hear ya. That's why we created Vera
Rubin stole the show, it's true. The cheapest tokens coming through.
10 times faster inference heaven. More special agents than 007.
Bluefield keeps agents' memory true.
Now let's talk about its CPU.
50% faster, that's outrageous.
Not for Vera.
It's built for agents. NVLink Fusion blends ASIC smartly.
Everyone's welcome to the NVLink party.
Well, if you like that introduction,
Vera Rubin's in full production. Nemotron Ultra leads the run. 5x faster work gets done. Nemo Claw keeps the guardrails right. OpenShell keeps the sandbox tight.
your code migrated and reviewed.
All before this song is through.
AI is a 5-layer cake.
Make no mistake. Global AI clouds build lots of gigawatts. ESX keeps power lean, connecting dots.
Every watt optimized for you.
So you can have your cake.
Can eat it too.
RTX Spark is finally here.
Biggest PC moment in
40 years. Agents powering all workflows. Running anywhere Windows go.
Harnesses run on CPU.
Models fly on GPU.
Cosmos builds worlds that robots need.
Turning compute into synthetic feed.
Out from IOCs and reasons through.
Understands roads like people do.
Who is how they learn to move.
Learning skills and finding growth.
Geometries powered by Thor.
The future's humanoid. Count on more. The future's bright, come see what's next.
Thank you, Taiwan.
Welcome to Computex.
大家谢谢。Have a great Computex. 大家谢谢. Thanks for an amazing year. Thank you for all your friendship and support. Thank you. Take care. Have a great Computex.